Hello, my name is Hao Jun Yao. I go to Keeling Middle School, and I'm fixing Austin's traffic problem for my creative project. So today we are focusing on three main topics to fix Austin's traffic: why Austin's traffic is terrible, ways on how to improve it, and the final coded product. Now, if you didn't know, I was born in Shanghai, China. And in China, we usually have light traffic and a bunch of public transit. This is an example of our public transit, the Shanghai Metro. And in my opinion, it's way better than what we have here in Austin. Wow, look at all that traffic. Here's the Loop 1 and Highway 290 intersection. And here's the Loop 1 and Loop 360 intersection. Here are some spots that have a lot of traffic in Austin. Now let's try to fix it. We can use the data from Google Maps and the Austin Census to make cases to tell us what to do. For our traffic data, we have 5 levels of traffic. Level 1 is for no traffic, 2 is for minor traffic, 3 is for noticeable traffic, 4 is for major traffic, and 5 is for severe traffic. This is the data from the Austin Census. It shows the amount of people per square kilometer in Austin. Let's now move on to the cases. Our first case is no change needed. As you can see, we have a traffic level of 1 and everything seems to be fine in terms of traffic levels. And the population density. Our second case is to build new roads. This road has a traffic level of 4 and 5 and is actually leading up to the Pennybacker Bridge, which also gets a lot of traffic. And it's all because of this intersection, where the lanes reduce from 4 to only 2. On to our third case, improving the roads. And we have a prime example of this in the 290 Loop 1 intersection, where the entrances into Loop 1 are really close, causing traffic jams, making an effect on Southwest Austin. Our final case is to build a metro or public transit. This case is usually applied in high-density urban places, like UT. So this is a map of Austin, and this is our public rail transit system. As you can see, the coverage is very small. Compare this to the city of Milan in Italy, which has light rail, commuter rail, and metro connecting suburban places to the airport and to downtown Milan. Now let's summarize. I used a 16 by 16 grid on top of the population and traffic to apply cases. These are our inputs for the code. And using these inputs, we can make requirements for the cases to apply them into our code. Now onto coding. Now, the code is mainly based on the two factors of traffic and population. And these factors make our 4 cases. I've also made tweaks to include the variability on some data to make it more real. So this is our result after coding, with 40 squares for new roads, 30 squares for improving, and 13 squares for metro. And this is approximately how many squares of each case will be left after we use certain budgets that are possible to use for Austin. And the good thing is, this works on other cities too, like Dallas or Houston. Well, I guess that's it for the video. Thanks for watching.